Hi, my name is Gabriela Sacoccio, and this is my Geo 168 final project on microplastics, ocean biodiversity in the face of the Pacific garbage patch. To begin, I wanted to explain what the Northeastern Pacific garbage patch is. This is an area of the world where circulating ocean currents have resulted in the accumulation of marine debris in specific high concentration gyres. So this region has become known as a garbage patch. However, it's important to note that this is not merely an island of floating trash, but rather consists of small fragments of microplastic floating just below the surface. This is an issue because plastic is a non-biodegradable material on a human timescale. Therefore, as plastic sits in the ocean, it breaks down into smaller and smaller pieces, but it does not completely disappear. This is causing harm to many species in the ocean because they mistake these pieces of plastic for food, and it can make its way through the food chain, and ultimately it is harming humans because we consume the animals that come out of this ocean. So in this project, I'm going to explore the impacts this plastic pollution is having on the biodiversity of the Pacific by mapping specific habitat distributions of threatened species according to the International Union Conservation of Nature's Red List. To begin, here is a map that shows the different gyres around the world, and below I've zoomed into the East Pacific Gyre, or the Northeastern Pacific Gyre, that shows how warm and cold currents circle clockwise to create this eddy-like situation in the Pacific. So the first animal that I examined is the leatherback sea turtle. It is labeled critically endangered for the subpopulation living in the Pacific Ocean. The rest of the population remains in the Atlantic Ocean. However, this population is only consists of 633 leatherbacks at this point, and its population is declining very rapidly. This animal's diet consists of jellyfish, so it is clear how it mistakes plastic bags as jellyfish very often, and it lives within the range of the garbage patch, so it is very vulnerable to eating high quantities of plastic. Here I have a map showing the species distribution of the leatherback sea turtle in the Pacific Ocean, and I have used a geoprocessing intersection analysis to show a polygon of where the leatherback sea turtle is at highest risk because it overlaps with the Pacific garbage patch. So the next animal I looked at is the northern albatross. This is a seabird that is labeled near threatened by the IUCN Red List, and it lives within the area of the garbage patch and often consumes pieces of plastic as shown by this picture here. Research has shown that the birds that eat high quantities of this plastic are dying off in higher numbers, such as in the 1980s when the birds were eating the most plastic and the population was the lowest. And in addition, their chicks that are fed highest quantities of plastic often weigh the least. This is a map showing the habitat distribution of the northern albatross, and the yellow is covering the entire garbage patch because the bird lives across the entire thing. Finally, I examined the yellowfin tuna, which is labeled near threatened by the IUCN Red List. While it is important to consider the declining population of this fish, I included it mostly to show the effect that this plastic pollution can have on humans. Tuna is one of the highest consumed animal or seafoods in the world, and because it's living in this region, it is possible that it's getting contaminated, and it's very likely that it's getting contaminated with chemicals such as BPA that are released from these plastics, and when humans consume the tuna, they are putting those chemicals in their bodies as well. And this is not merely urban myth. There's actually research that's starting to be done, and it has been discovered that about 93% of the human population tests positive for having BPA in their system, and this can be attributed to food and drink sources. So a lot of nations are starting to limit the amount of BPA that's allowed in their products, such as in food, packaging, and Canada has become the first nation to outlaw this chemical entirely. So finally, I have a map here showing the yellowtail tuna habitat distribution, and again, it overlaps with the Pacific Garbage Patch. This is my final map. It shows the the findings of a boat that did some trawling through the Pacific Garbage Patch, meaning it took a net like shown here and it just went through and gathered pieces of plastic and then sampled the concentration of pieces per square kilometer. It's clear that there is the highest concentration within the area of the garbage patch. However, what's very concerning is that there is plastic at nearly every sample location that the boat visited, meaning that this is a problem not only affecting the animals and the biodiversity underneath the red area and the garbage patch, how it's just affecting the entire ocean. And this is an image showing some of the results from the samples. Here are my works cited, and I would just like to say that the changes needed to address this problem have to begin on the land, where we can stop using single-use plastic materials such as straws and plastic utensils and replace them with things that are reusable, such as glass straws and reusable forks and knives. And this is part of the zero waste movement that I am going to try out myself this summer. Thank you.